This problem is the bottom of page 2 in part 2 where we started talking about pH. The question is, what is the pH of a solution with an H plus concentration of 3.76 times 10 to the negative 10th molar? So again, first thing you need to do is look over to your equations and figure out, all right, which one has pH and H plus in there, and it happens to be the very first one. So if you look at the equation, it has something that might make you a little nervous, log in here, but it's very easy to use the calculator to figure this out. So we write down the equation first. So we have pH equals negative log H plus concentration, and then you plug in what's known. In this case, we know that the H plus concentration is the 3.76 times 10 to the negative 10th, so we just plug that in. So there's our negative log. And then there's our problem here. So we're solving for this here. So to put this in the calculator, it depends on what kind of calculator you have. If you have a TI-32S like this guy, you would actually type in negative and then find the log button and then type in this number and then hit enter, and that would just give you the answer. That's as easy as it is. Some calculators make you put in the number first and then hit log and then hit negative. You're gonna have to play around. This is how you play around with it. Once you get it in the calculator, you're looking for this answer. You're looking for the pH would be 9.4248. I didn't round for sig figs or anything, but plug it into your calculator, see how you get this, and then that's how you know you're using your calculator correctly. So you get 9.4248. Now sig figs with pH is a little weird. This has 3 sig figs here. With pH, anything past the decimal point, any whole numbers, don't count. So for sig figs, you just ignore the 9. You need it. It's very important because it does tell us that it's basic. But this would be the first one, this would be the second one, this is the third one, and then you use that to round. So this is an 8, that rounds that to a 5. So that means we have 9.425. That happens to be our pH and the answer. There you go.